Greetings, this is Mark Anderson for Kellogg Community College, and I'm going to be looking at piecewise functions. This is going to be one of those things that's going to be a little tough to do because of the way that ScreenDraw works with my video editing software. I'm going to have to, unfortunately, have this picture go away several times as I explain it, because what you really have in a piecewise function, you have 2 or 3 or 4 parts that actually exist on one plane. This graph, this 2x, is y equals 2x plus 0. So it starts at the origin and moves up to over 1, but you'll note that it exists when it's less than or equal to negative 1. So that means at negative 1, there is a kind of filter. I call it a filter. That means that on the left-hand side of that dotted filter, and it's not an asymptote line, it's just something that I've kind of used to teach this stuff here. On the left side of that filter, I'm going to have this equation, y equals 2x plus 0. Now on the right side of the equation, I'm going to have y equals x divided by 2 plus 0. And this is, again, because it has no y-intercept, and this is going to go up 1 over 2, up 1 over 2. This is going to go up 2 over 1, up 2 over 1. So what I'm about to do is show you how I'm going to actually see this here. And let me kind of get to my graphing calculator for a moment, because I'm going to kind of do stuff on that. So if I go to the graphing calculator, I will kind of show you that on my y equals, hold on, boop. If I go to my y equals here and clear out my equation, I'm going to have 2x. So here we go, 2x. And so this 2x on my graph is going to exist until we hit this negative 1, this vertical line that is not actually on the calc. And then after that spot, we're going to have x divided by 2, and then we're going to have this line. So this line will exist at that moment after it. So because that's kind of far away, I'm going to kind of move it over here too, just so we can kind of see it as we freeze the screen. If you can imagine on the graphing calculator a dotted line that represents that negative 1 changing place, we're going to be kind of traveling along this steep y equals 2x line until we hit that zone, that negative 1, and then we're going to be switching over to this line right there. So you can see that both lines are on the screen, but we're in fact going to be switching over from here to here at that negative 1 spot. So what I could do is use my table. The table is pretty handy, because what I could do is just check to see, like, oh, what is the, you would type this equation in, and the equation would then say, oh, at negative 1, my value is negative 2. So here's that. Now you'll see me putting a solid dot here because this is less than or equal to, and that means I can put a solid dot there. And then I'm going to find one more point that's easy to plot, so negative 2 comma negative 4, which again is found on my table of this y equals 2x. I also could have figured it out by knowing that this goes up 2 and over 1, so backwards it would be down 2 over 1, and this would be my line up to that point. But when I hit that point, I'm noticing that I'm going to have to go and look at the next equation, which would maybe be in my y sub 2, this x divided by 2. Now I see that at negative 1, it is at a negative 0.5, so it's here. But you'll see me draw an open circle because I want to open circle because it doesn't actually touch that. That would violate the vertical line test, and these are functions. So from that moment, I'm going to have an open circle, and it looks like another easy point, if I go check my table on x over 2, is going to be it actually intersects the origin, which means that I'm now going to have a very smaller, like you can kind of see in my graph right here, you see it's just going to kind of slowly increase. And from this point, it goes up 1 over 2 because that is its slope, up 1 over 2. And I can just keep that going and going and going. And now I have my piecewise graph, but I gotta make sure that that actually connects to my open circle there. So in review, this graph was 2x, 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 2x until it got to negative 1. It landed on negative 1 for my vertical line there, and then jumped to this equation. It's an open circle because of greater than, and now it's x over 2, x over 2, x over 2, x over 2 to positive infinity. So that is your first piecewise function. Now our second and last piecewise function example here is going to be something that has 3 different parts. Now what I want to do is kind of like look at the zones that I'm going to use or my filters for this spot. You'll note that I have a filter at 1 because I have an answer here where it says x is less than 1, so I'm going to have a filter there at 1. I'm going to have a filter there at 3 as well because I've got a function on the right. So I have a function on the left, I have a function in the middle, and I have a function on the right. Well, let's put all 3 of these functions into the graphing calculator and then kind of see where they go on the problem. I'm going to move the calc all the way up here. I'm going to first of all start by typing in my absolute value of x. Now to do so, I would then make sure that I'm in y1, I'm in my first equation. So I click the math button and move over to the number category. Now it says abs. I hit enter, and then now I put my x in that because this is now the absolute value of x, and I see my v. That's my first equation. And it exists until I get to 1. So it's going to exist, and then all of a sudden at 1, it's going to stop. Now I'm going to have x squared. X squared is going to be with x and a little 2, and so that's a curve right there. And that's going to exist until I get to 3. Then I'm going to have a third equation, and that third equation is going to be negative x plus 2, and then bam, there's my third equation. And that equation exists at 3. So if I had to use a colored pen to tell you how this is going to look, my first equation was that absolute value. So I'm going to try to draw this very carefully here. I am going to be on that absolute value problem, until I get to 1. Now I'm going to change to a new color. I'm going to change to a light blue here. And then from the 1 to the 3 on my x, I'm going to be riding that curve. So I hopped off my v, and now I'm on the curve until I get to this point way up here at 3, 9, because that's where I would end, 3, 9. And then I would then hop to my final destination, which would be here at 3. At 3, I would then pick this up and continue going with my green line. So I'm going to kind of use these colors to show you how it occurs over here. So starting off with my blue color, I am going to work with the absolute value of x, which if I looked at my table for y1, I would have a dot at the origin, a dot at negative 1, 1, a dot at negative 2, 2, and that would give me a v going this way. Now since this only goes up to 1, then this would go up to 1, 1, but it would be an open circle, and it would be an open circle because this absolute value equation only went to positive 1 on my x. Now I'm going to choose a different color. I'm going to go to the light blue and use this parabola. If I looked at that parabola is going to exist between 1 and 3. Now there was a dot at 1, 1, which you'll note that I now get to fill in this dot so there's no gaps. I then go from 2, 4, and then I go to 3, 9. So by connecting these dots very carefully, it looks actually linear, but it's more of a curve right there. It curves up a little bit. It curves up a little bit faster, and this is going to be an open circle at the end. And the reason why it's going to be an open circle is because I don't actually get to that spot. If that was a less than or equal to sign, I could fill that in. And so for my final part of this graph, I'm going to choose to green, and that's going to start at this equation of negative x plus 2, and I'm going to go to my table. If I go to my table, I would see that at the 3 value on my x, I would be negative 1 value on my y. And then I'm going to go then down 1 over 1 and just keep going down at this 45-degree angle until I go off the grid. Now you'll note that the first dot I did plot has a closed circle, and it has a closed circle because it was greater than or equal to 3. So it goes your absolute value line to an open circle, then a closed circle, which will then fill that in, parabola that would take you all the way up to 3, 9, which it does and has an open circle, and then this closes, and this goes down 1 over 1. And again, all of these were found using the tables. which I couldn't demonstrate to you because as soon as I click on the calculator again, all of my coloring will go away. So be sure to lean on the tables and be sure to do maybe one equation at a time and create these little filters so that you know when to switch from one equation to the other. Well, thank you very much for watching. I hope you learned something, and I will see you at the next video.